Okay, here we go. Another problem where we know the population standard deviation. So I strongly advise you guys to read first the questions, try to answer the questions yourself, and then watch the video. Okay, so why don't you pause the video now, try to answer it. It's much better for you guys. So here what we have, the mean of a random sample of 25 observations. So this is our n, of a normal population with standard deviation of 50. So we know that this is sigma, all right, and is 200. This is the mean, so this is x bar. All right, so let's note these down. Here we go. This is what we have just read in the first paragraph. Now part A, estimate the population mean with 95% confidence. So this is 1 minus alpha, you know that by now, so which will allow us to find alpha over 2. Okay, and here we go. So we need to find z of alpha over 2. Again, it's the z value such that the area on the right hand side is 0.025. This is z value that we found in the previous problem, so I'm not going to illustrate it again. It's 1.96. Okay, and this is the justification or the explanation. How did we get that from the z table? So just plug it now and we find that the interval is between 180.4 as a lower level and 219.6 as an upper level. And now we need to repeat what we did in the first part, but now we are changing the standard deviation of the population. In the first part, here 25, then to 2. So let's deal with that one now. So what changes, in fact, when the population standard deviation change? Nothing will change about z, right? Z alpha over 2 is exactly the same because what the confidence level did not change. All what will change in our calculation is that sigma is now 25, which will change the sampling distribution, which is sigma of the square root of n. So now with sigma is equal to 25, I'm going to replace this new value in my confidence level formula. So while before it was 50, now it's 25. So my what I'm adding is 9.8 now. And you can see that the confidence interval is between 190.2 and 209.8. All right, now what happens when sigma is 10? Again, the change is very minimal because it will change only that part in the confidence interval calculation. Here we go. So you can see that now this is 10. Okay, while on the top it was 25. And you notice now what's happening to the confidence interval. So what was happening from part A to part B to part C is that as sigma was increasing, as you can see, the effect here is very, very clear for us. Sorry, the sigma was decreasing, meaning that the whole thing here is decreasing, which means the width is decreasing. And look at this, you can easily compare these two. All right, and you can see that as sigma decreases, the confidence interval width will get smaller, which is a much better information for the managers. All right, the last problem. This entails a case where we don't have the population standard deviation. So here we're talking about digital cameras where it's about the number of pictures that are stored or they are taken from the camera into your computer. So here we go. This is a question: how many pictures were stored on computers coming from the cameras? A random sample of 10 digital cameras owners produced the data given here. Here we go. So this is the number of pictures that were transferred from the camera to the computer. And they want us to estimate with 95% confidence the mean number of pictures stored on digital cameras. All right. So, which is the population mean. So what do we have here? Here I don't have X bar even. I don't have the population standard deviation, but I have the observations themselves. And with the observations, I can find X bar, right? All what you have to do is sum these up, 25 plus 6, 31 plus 22, etc., and divide by 10, and this will be X bar, right? So the sample size is 10, very easy, just count these. And in fact, it was told to us that he got information from 10, here we go, from 10. And the X bar is very simple calculation, 17.7, so sum up, divide by 10. And the standard deviation, this is a sample standard deviation, so we denote it by S. How to find that? In fact, what I did, I used Excel, so it's standard S, and I simply selected these. It's very easy, but if you want to do that manually, what do? Now that you have X bar, for each of these values, you do 25 you do the difference between the value and X bar, you square it, you sum it up, you divide by 9, which is n minus 1. This will be your variance, and then you square root it, and this is S. This is a calculation method that we have learned in the first part of our course, so it's really not necessary to repeat it here. You can use Excel to find it. It's a very simple way to do it. All right, so now we have everything. We have X bar, we have S, we have N. But remember, when the population standard deviation is not known, we are not using Z anymore, we're using T. And the confidence interval is given in the term of T's. So first, let's find alpha over 2 that we are looking for. 1 minus alpha is 95%. So this is 0.95. And we're using this confidence interval calculation because now we are using T instead of Z. And you notice that we don't have sigma anymore, but we have S, right? And everything else is the same. So alpha over 2 is equal to 0.025, so which is 2.5%. And I need to look for the t value. But to look for the t value, first I need to know which row to use, so which degrees of freedom. Remember, the degrees of freedom in nu is equal to n minus 1, okay, which is 9 in our case. So now we know the area, so this is nu, sorry. And we get 9. So we know nu, we know the area, and these are the two parameters that you need when you want to find the t value. So let me show you an extract of the t value, okay, where let me just clear it up because I don't want you to get confused with these lines because they have nothing to do here with what we are trying to find. All right, here we go. So let me go back, get back my pen. So we're looking for the t value such that the area on the right hand side, okay, which you can see here in the blue area, is 0.025, which we can read here. Here we go. So we have to look into that column, but that column has many rows, and we look for the row that corresponds to the degrees of freedom that we want, which is here. It's 9. All right. So we can see that the z value corresponding to that, it's 2.262. So let me write it down here. Here we go. It's 2.62. And you notice that whenever I want to show a t, or I want to specify the value of t, I am specifying exactly what that t. This t that corresponds or has parameters of nu of 9, and the area on the right hand side is 0.025. And this is 2.62. Now we can plug it into the confidence interval formula. And this is the X bar that we calculated from the observations. This is our T. This is S, the standard deviation that you also know how to calculate it from the observation. This is the sample size. Everything is now familiar. And we get a confidence interval of 11.2 and 24.2. All right, so I hope that you found these problems useful for you. I strongly advise you to try to solve them on your own. If you have any clarification or any question, you know how to contact me.